Hey guys! So we've already hit arithmetic sequences in series. Today we are going to learn about geometric sequences in series. So what makes a series geometric or a sequence geometric? Um, it's geometric if you have to multiply or divide to get to the next term. So since we're multiplying or dividing, we no longer have a difference because a difference implies that you subtract to find out what that number is, which is what we did for an arithmetic sequence. Here, since we're dividing to find out what we're multiplying by every time, that's our ratio. So we have a common ratio between terms. So this time, R is the guy that's telling us what's happening between each of our terms. So, an example of a very simple geometric sequence. So, 2, 4, 8, 16. What's happening there? So, what's happening is from 2 to 4, and from 4 to 8, and from 8 to 16, each time I'm multiplying by 2. So since I'm multiplying by 2 every time, that means that R is 2. Now let's think about how we're supposed to go and write that out. And obviously I have the equation down here, but I want to tell you how we actually get there. So one thing I want to remind you of is anything to the 0 power is 1. So we know that our first term in this guy is supposed to be 2. And I know I get my next term by multiplying by 2. Okay? Now if I just have 2 times 2 to the n. Now for the first term, if I plug in 1, then I really have 2 times 2, which is 4, and that's actually my second term, right? So if I subtract 1 from my term number, all of a sudden it works. If I plug in 1 for my first term, I get 2 to the 0 power, which is 1, and 2 times 1 is 2, so that gives me my first power. Okay, let's take a look at this next one. So from 4 to 2, we divided by 2. From 2 to 1, we divided by 2, and from 1 to a half, we divided by 2. However, that is not how we write our common ratio. We write it as what do we multiply by every time. And what we multiplied by every time was really 1/2. So remember, we can always find this by taking the second term and dividing it by the first term, or the third term and dividing it by the second term, dividing successive terms by each other. So my first term was 4, and then I multiplied it by 1/2 for every new term. So for the nth term of any geometric sequence, or the explicit formula of a geometric sequence, a sub n equals a sub 1, or the first term, times the common ratio to the n minus 1 power. Remember, the reason that we have an exponent here is because this common ratio is happening several times. So when you multiply something several times, r times r times r times r times r, then we take something to a power, right? So I just wanted you to know that wasn't just being pulled out of somebody's butt. That's just literally how repeated multiplication works, right? Cool. All right. So given the geometric series 1, 6, 12, 24, find the common ratio, the explicit formula, and the 10th term. So the first thing we want to do is find the common ratio. So the common ratio is what I multiplied by every time. So I can tell pretty easily that we multiplied by 2, because that's easy to see. But that might not be as easy to see when you're multiplying by some really bizarre number. So here's my advice. Take the second term divided by the first term. That will give you R. Okie dokie. Bomb diggity. Okay, so the explicit formula. So remember, our explicit formula, a sub n, is equal to the first term in our sequence, which was 3, times my common ratio, which was 2 to the n minus 1 power. Good deal. Ugh. Now we want to find the 10th term. So I want to find a sub 10. So that means I need to take 3 times 2 to the, and I could put 10 minus 1 there, but I'm just going to put to the 9th power. Now if we take 3 times 2 to the 9th, we are going to end up with, let me see my calculator here, 15, whoopsies, that's a bad 5, 36. Good deal. All right, so now that we are given the sequence, we are given all those little pieces of information, it's really easy to find the explicit formula and then to pop in a number to figure out whichever term we're looking for. Now what we want to do is, given some information, go and find the explicit formula for the geometric sequence. So here in the geometric sequence, they're going to say that my second term was 3 and my fifth term was 24. So here's what I know. My fifth term is equal to my second term times my common ratio happening third term, fourth term, fifth term. So 3 times. Okay? So what can I put in for a sub 5? That's 24. What can I put in for a sub 2? That's 3. And then r times r times r is r cubed. So now we'll solve for r. Divide by 3 on both sides, so 8 equals r cubed. So to get rid of a cubed, we have to take the cubed root. Or you might remember that 2 cubed is 8. So now we know our common ratio is 2, right? All right. Now, if a sub 2 was 3, to go backwards to get a sub 1, I need to divide by 2. So I'm going to take 3 divided by 2. So a sub 1 is 3 over 2. Woohoo! All right, we got our first term, we got our common ratio. Now we can go ahead and find our equation. So a sub n equals, my first term was 3 over 2 times the common ratio we figured out was 2 to the n minus 1 power. Okay, now let's look at this next one. So a sub 4 is 125, and a sub 10 is 125 over 64. Okay, we got this. So the 10th term is equal to the 4th term times the common ratio happening 6 times from 4 to 10, right? So from 2 to 5, our common ratio happened 3 times because 5 minus 2 is 3. So over here, our common ratio will happen 6 times because 10 minus 4 is 6. So I'm going to put in what I have for a sub 10, that is 125 over 64 equals 125 times r to the 6th. So the next thing I'm going to do is I'm going to divide by 125 on both sides. So that will leave me with 1 over 64 equals r to the 6th. And then we'll take the 6th root of both sides. Remember, that's also the same thing as taking it to the 1/6 power. That's an option as well. The 6th root of 1 over 64 is a half. Good deal. So now let's work our way backwards. So we have a sub 4. We can now find a sub 3, and then we can find a sub 2. So then we'll be able to have a sub 1. So now we're going backwards. Instead of multiplying by 1/2, we're going to be dividing by 1/2. Remember, dividing by 1/2 is the same thing as multiplying by 2. So let's work our way backwards. Our fourth term was 125. We'll divide by 1/2 and get 250. We'll divide by 1/2 again and get 500. And then we'll divide by 1/2 again and get 1,000. So now we know a sub 1 was 1,000. So my nth term is going to be a sub n equals my first term, which was 1,000, times my common ratio, which was 1/2, to the n minus 1 power. All right, so now we're going to look at the sum of finite geometric series. So when we have a geometric series and we only have a certain number of terms we're adding together, this is how we're going to find it without our calculator. So remember, we can always put this into our calculator if we, if we want to double check our answer. But especially IB kids, next year when you take your IB exam, they're going to have you do this by hand. So probably the numbers won't be huge, but you'll have to do it by hand. All right, so first of all, to find the sum of a finite geometric series, we have to take the first term and multiply it by 1 minus the common ratio to the how many number of terms power you have, all divided by 1 minus the common ratio. One thing I want you to be careful about. If r is negative, you need to make sure that you put 1 minus r to the n on that one. Okay, I know it's really tempting to do, oh, minus a negative is plus a positive, so change that. Don't do that, okay? Then that changes because remember, if that's in order of operations, exponents takes place first, and so that's going to tell you the sign of whatever that number is on the inside. Because remember, if you take it to an even power, it'll end up positive, then you're still subtract. Either way, use parentheses, okay? Don't think you're smarter than your calculator. If you're getting silly answers that don't match when you put in the sigma notation, that's probably why. You're not using your parentheses around that r on the top part of that equation, and that you're changing it up. Okay, cool. Let's evaluate this series. So we can absolutely put that into our calculator like I showed you earlier. Or we can just say, okay, so the first term, okay, so what is the first term? First term is usually the number that's multiplied in front here, right? Since nothing is multiplied in front, technically that's a 1. So a sub 1 equals 1. Our common ratio here is 2 because that's the number that has our exponent on it. So now we'll go through to find the sum of the first 9 terms. I'm going to take my first term, which is 1, times 1 minus 2 to the 9th over 1 minus 2. So then we'll go ahead and just pop all of that into our calculator, or you can go through and solve it by hand if you know what 2 to the 9th is. But either way, we will end up with, let me search there we go. We end up with 511. All right, over here on this next one, if you notice, the power is not n minus 1. So we have to figure out what is our first term. So we need to plug in 1 for our first term. So 0.3 to the first power is 0.3. 4 times 0.3 is 0.12. Our common ratio right here is still the one that has the power on it, so that's 0.3. So to find the sum of the first 12 terms, I need to take my first term, which was 0.12, times 1 minus 0.3 to the 12th over 1 minus 0.3. So then we'll pop that into our calculator, and we'll end up with about, so I'll put a little squiggle there for the approximation, 0.171. All right, so next time we're together, we will talk about what happens when we start taking the sums of infinite series. When we add together all of the numbers in a series, what happens? We'll see. See you soon.